need to be able to find reference angles and use them to find exact angles of trig functions. So we're going to use a reference angle to find all 6 trig functions for 11 pi sixths. Now thinking of where 11 pi sixths is, that's 1 of the pi sixths shy of 12 pi sixths. So that's going to be right over here. The reference angle then, the small angle here, is pi sixths. And so all of the trig functions for 11 pi sixths are going to have the same value as the ones for pi sixths, except that we need to consider the quadrant that 11 pi sixths is in. We may need negatives on them. So let's go ahead and figure out cosine of 11 pi sixths, and that's going to be the same as pi sixths, because we know if whether we were in quadrant 1 or in quadrant 4 that the cosine values are the same. So let's think of pi sixths unit circle values. That's square root 3 over 2 and 1/2. So cosine is going to be square root 3 over 2. Sine of 11 pi sixths, now in quadrant 4, sine values are negative, so I need to put a negative on that. And now let's do tangent of 11 pi sixths. And tangent of 11 pi sixths would be sine over cosine. So we can use what we have there and divide those. And then when we flip this one over, the 2's will cancel. So that's going to be negative 1 over square root 3. Now the others are just easiest to get by doing reciprocals, and so secant of 11 pi sixths is going to be the reciprocal of cosine, which is 2 over square root 3, and cosecant of 11 pi sixths is going to be the reciprocal of sine, so that's negative 2, and then down here we'll do cotangent of 11 pi sixths, and that's going to be the reciprocal of tangent, or negative square root 3.